Hello and welcome back. In this segment we're going to look at input and output in your C programs. So printf statements for output and scanf statements for input. There are only a few tricky parts of this. This won't be a long segment. You have to know how to output and input all of the different data types that we now have to work with. So in the previous segment we learned about all of the data types that are in C, and when you're doing input and output you have to be careful that your format specifiers are matching the data types of the variables that you're inputting data into and outputting data from. So let's have a look at the printf and scanf statements for input and output in C language. Okay, so we're talking about printf and scanf, and we'll look first at outputting text onto the screen, and this is a very simple one that we've already done. In the very first program we did a printf function call, and inside of the double quotes whatever you put there will appear on the console window. There are a couple of things that you put inside of these double quotes that don't appear on the console window as they appear inside of the double quotes. So the first one is something called an escape character, and they always start with a backslash. Make sure you know the difference between a backslash and a forward slash. This is a \n, and the purpose of the \n is to go to the next line in the output. So if we want to output multiple lines, we can use as many \n's as we want to, and this is one of the escape characters. We also have something that goes inside of the double quotes called a format specifier, and these things start with a %. Some people call them % sequences. I think it's more correct to call them format specifiers, and we'll have a look at what the purpose of those is for outputting data onto the screen. So here's your first example of using a format specifier. We have an int variable called variable, and the format specifier is %i. So this would output variable contains 12. The value in the variable outputs to the console in the position of the format specifier. Here's another example. If we wanted to output a double value, we would use the format specifier %lf. That looks like one f, but it isn't. It's lf, and that corresponds to the double variable here, tax rate, and this would output the tax rate is 0.070000. So the default for the %lf format specifier is 6 places of accuracy past the decimal. Not always what you would want. So we have % sequences that we use for output where we can specify something other than the data type. For example, in the tax rate one we just looked at, it might have been more appropriate to use %.2lf, which means 2 places of accuracy past the decimal. You can also output more than one variable in a single printf, or different types. So this one has a %i format specifier and a %.2lf format specifier, and it will correspond to the int variable here and the double variable here. Those come in order. So the first number here corresponds to the %i, and that had better be an int variable or an int value. And this one, the second one, corresponds to the second. You can have as many of these as you want, and they correspond to each other in the order that they appear. Now let's look at inputting data from the user. So we have a variable declared called myInt, and we want the user to enter a value that will go into that variable. So for this we're going to use the scanf function. The scanf function will stop and wait for the user to type the value. So you don't want the program to just stop and the user not know why it stopped there. It looks like it crashed or something. So we're going to output a message to the user that says enter whatever it is that your program wants. In this simple case, just enter an integer, and then the program will stop on this scanf and wait for the user to type the value and hit enter. So the user has to hit enter for the value to go into that variable myInt. Notice that there is an ampersand here. So on the scanf you need to put an ampersand before the name of the variable, and you will forget that and it will be very painful. Sorry, I know you'll do that. So just when something is going wrong with your input statements, check first to see if you have included an ampersand before the name of the variable. It's difficult to remember that because I'm not explaining exactly what the ampersand does. We're going to explain that in a later segment. So on the printf statement, you don't include the ampersand, but on the scanf statement you do. So here's a brief example where I show a prompt message where you ask the user to enter a tax rate and go to the next line, and then the scanf statement using %lf reads the value the user types into the variable, and then to make sure it's actually there, we'll spit it back out onto the console immediately saying the tax rate is %.2lf, and so no ampersand here, but we are allowed formatting in the output, and distinguish that from the input, the scanf statement, where we do use an ampersand, but we cannot format the input. So you can't specify that you insist that the user enter a specific accuracy or something. You can only specify the data type that you're expecting the user to enter. So here are the escape characters that you can use inside of the double quotes of your printf statement. So you can go to a new line, you can do carriage returns, which means just move the cursor back to the beginning of the line. You can output tabs, it's not particularly useful. You can move the cursor back one space. If you want to print out a backslash, you do it by saying \\\, and the second backslash is the one that would get printed. The first one indicates that the second one is one that you want. Similarly, single quotes and double quotes, if you want to output those, you have to precede them by a backslash. Vertical tab is not used very much. Ringing the bell is not used very much. You can imagine an old teletype machine in the 1970s, and you'd want to ring the bell saying that a telegram had arrived. That's something that would have been used for. I think it will still beep. I'm not sure if it will cause the speaker on these machines to emit a beep. I think it will. And form feed is also a fairly old escape character that would control the paper on a printer of some kind, spitting out one form, getting ready to type on to the next one. Okay, so the format specifiers that you have correspond to the data types. So in the previous segment we looked at the data types that are available in C, and now when you're doing input and output, you have to use the appropriate format specifiers. So don't guess the % sequences. It just causes problems. Keep a copy of this handy and use the % sequences that correspond to the data type that you actually have. If you get them wrong, it's perhaps even more annoying. Occasionally, if you get them wrong, it will do what you wanted it to do anyway, and then sometimes it won't. So use these and you'll get used to the most common ones that correspond to the data types that you use the most often. Okay, well, for output you have a lot more control over what's going on. You have not only the way of specifying the data type that you're using, but you also have a way of specifying things like the precision of the floating point number that you're outputting to the console and the width of the value that you're outputting to the console. So for example, if I wanted to output a double value with 9 places in the output and 2 places past the decimal, I could use %9.2lf. So F is for float and LF is for double, and not every possible combination of the things that you can do are on here, but you can use this as a guide for the ones that are commonly used. And we're going to go into the development environment and play with these so that you'll start to get a feel for the formatting sequences for outputting values onto the console. Okay, we're in the development environment now, and I've made a new project called Play with I/O, and a C program that we can use just to demonstrate the printf and scanf functions so that you'll be a little bit more comfortable, I encourage you strongly to open your Visual Studio and type along with this. It makes a big difference if it comes off of your fingers. So here's the very simplest one. We are outputting hello to the console, and I can put some carriage returns there so that it will move down, and let's just make sure that that's working so we have what we want. Okay, we have someplace we can work. We can do an output statement, and each one of these \n's went to a new line. Let's declare a couple of variables up here, myInt, and we will put in it any value, 1, 2, 3, and double tax rate. Take the one that we had from the slides, and we'll ask the user to enter the tax rate eventually. So let's play with outputting the int variable. So you can use %i or %d for this. After the double quotes are closed, you put the comma and then name the variable that you want to correspond to that formatting sequence or that % sequence. So what we have now is, space would be better there, it's outputting hello, and then in place of the %i, it's outputting the value that is here. And the data type of the variable here must match the data type of the format specifier. And you can use as many of these as you want. You can put %i, and what's over here doesn't actually have to be a variable. It's any int could do. There's 456, which is an int value. It's an int literal, and it will correspond to this %i, and that shouldn't surprise you that we have hello 1, 2, 3 and then 4, 5, 6. So let's output a prompt. We're going to ask the user to enter the tax rate, and I'm not going to put a carriage return there. I'm going to allow the cursor to stay right on that line, and then I'll do the scanf, and inside the double quotes, %lf, no \n's, and no formatting on the scanf. What we do use on the scanf is the ampersand before the name of the variable. And I'm going to output the answer right away, echo it back to the user what they entered. So I'm going to put the tax rate is, and I'll put %.2lf because we know what that does, and a \n. So notice the difference between the input and the output. The input statement requires the ampersand. The output statement cannot have the ampersand, but the output statement can have this formatting thing that controls what it looks like on the console. So let's run that and see if it does what we expect it to. So it says enter the tax rate. I'm going to put 15.239, and it echoed back the tax rate is 15.24. So where did it get the 24 when we put in 239 past the decimal? It doesn't mean that there is 15.24 in the variable, but the format that we asked for it to be output was 2 places of accuracy past the decimal, and it will round to that accuracy. So 239 became 0.24, and there's our hello from the last time. So what I'm going to do now is show you a trick that is helpful when you're trying to figure out what all of these formatting statements do in the output. So I'm going to make a number line so we can look at that and help us to understand what happened with our output statements. So I'm just going to put something in the tax rate here. Let's put 87.65. That's a pretty high tax rate, but I'm just thinking about looking at the output statements. So in this printf statement, I'm going to start using the width specifiers. So let's put %10i \n, and then I'm going to output the int variable, myInt, which has 1, 2, 3 in it. So let's look at what this width specifier for an int value does, and you should see why it's useful to have this number line here. Okay, so here's the number 1, 2, 3 output in 10 places, and you can use the number line to see that we did indeed use 10 places of output for outputting the value 1, 2, 3. Okay, here's something that's also helpful. You can put these vertical bars in your output to help you understand what's going on in the output. So if I put now, for example, I'm going to say %10.1 LF, and I'll put another vertical bar. The purpose of the vertical bars is just so that you can see what does that width specifier do. And now I'll put the tax rate here. Okay, let's run that and see how the output looks using the width specifiers on both the int and the double value. So we can use the number line again. 2 through 1, we have a width of 10 places, and the int value is right justified in those 10 places. And then we have 10 places for the floating point number, 87.7, because we specified 1 place of accuracy past the decimal. And these bars are not really part of the output. They're just to help us visualize what's going on with this. Remember, the minus sign we talked about in the slides can be used to left justify the numbers in the width. So now we have 1, 2, 3 in the first 3 places of our 10 output spaces that we've allocated. And similarly, we can left justify the floating point numbers. I'm going to take those left justify minus signs out and just make a few more duplicate printf statements and put some random integer numbers in here and some double values. If you're making a table in your output, you're asking your C program to generate a table of values. It's very easy to do with these width specifiers and make your output appear in columns. If you try to use the tab character, the tab escape character /T, it's really difficult, and using width specifiers turns out to be pretty easy. I had promised you that I would check and see if \A still rings the bell. It does still ring the bell. In case that's interesting to you, if you write a program that you need to have sound coming out of it, there's one way to do that. Put \A's in your printf statement inside of the double quotes. Not too useful, but the width specifiers, the accuracy specifiers for floating point numbers, left justifying your output, those are going to be quite useful to us. Okay, let's have a summary now of the things that we've looked at in this segment. Okay, just a brief summary then of what we've done in this segment on input and output. We've been using input and output from the console window, not from files. So there is such a thing in C as file input and output, and we are going to look at that in a later segment. So we've been using scanf and printf for input and output. We also looked at the escape characters. These are special characters that start with a \. You have to know the difference between a \/ and a /. Escape characters are used to control the position of the cursor on the console. A few other things, but mostly that's what we're going to be using them for. Also, we looked at the % sequences, which are the format sequences that you use for input and output. So these % sequences are used to specify what kind of data or what data type you're doing the input and output for. You have to be a little bit careful that you don't try to format the input. So scanf, what goes inside those double quotes, is really pretty specific. You can't specify width or places past the decimal, and if you do, you'll kind of get garbage as a result. So it's a good idea to use the debugger. Don't guess the % sequences, the format sequences. Print a copy of this table that was provided in the PowerPoints and keep that handy. So if you just try and guess and you get the wrong answer from your program, it might mean that it's the output statement that's wrong or the input statement that's wrong and the rest of the code is correct. So you have to be a little bit careful that you're using the exact ones that you intend to, matching the data types that you're using. And a bunch of you will forget to put the ampersand preceding the variables on your input statements. So the scanf requires the ampersand, and the printf does not. The reason people forget this is because they don't know exactly what the reason is for having that ampersand there. And again, that comes in a later segment. We just have to get some interesting programs running so that you can write some C code and learn the primitive parts of the language. And we looked at in this segment prompting the user. So an output statement that tells the user why the program stopped and what it's waiting for. So enter the something and then the program stops. And an input statement without a prompt is really not being very nice to your user. You just run the program and it stops and no one knows why. Okay, I hope you're enjoying it, and I'll see you in the next segment.